Okay, Quad have actually helpfully incorporated a flow chart into their service manual, which is actually helpful. And I'm running through it now, and it says, I don't know if you can read this, it says on the start, and it says, will the tuner turn on? Yes, it will. Do the indicators function correctly? No, they don't. So the station indicators don't work. They will light, but you can't select them, so we'll say no. And does more than one of the LEDs illuminate? Well, yes, it does, because after a while it looks like it turns on one of the preset channels. So he says yes. And diagnosis K. So diagnosis K, according to the service manual, suggests page too far here. Diagnosis K is faulty IC1, which is one of the problems that it's got. And also, if you continue here, if you say that the function, the station indicates tune correctly, does the display function correctly? Yes, it does. Does the tuning knob function correctly? No, it doesn't. So you follow node down, and node takes you down to, is the mechanical operation of the knob okay? Yes, it is. You follow yes, track yes down, and it comes to, with the tuning selected, does tuning knob vary frequency? No. And then it says diagnosis X. And interestingly enough, you come to diagnosis X. Diagnosis X suggests that RV4 is open circuit, dry joint on low and high voltage reference. No, it's definitely not that. IC1 unserviceable, pin 12 should be logic high to operate the analog switch. So I think that's the next step to do, is to have a look at the pin 12 of IC1 and see if we can see if that is actually going logic high. Because it's the beam end run at the end of its stop, I probably think it might actually be stuck on logic high all the time. You can't turn it off, and the microprocessor is actually the problem. IC1 is this socketed IC here. Actually, interestingly enough, you see when I rock the tuner about, there's a bad connection there somewhere. I'm not sure if that's the tuner or what that is, but there's obviously a number of faults with this thing. Yeah, I'm wriggling I'm wriggling the chip around in the socket. Now, I think there's probably a number of faults. I think it's probably a bad connection, but I think this chip is actually dying. Anyway, let's have a look at pin 12 on the scope. Let's get a scope probe. So if it's logic high, we're looking for about a 5 volt per division. So put it on 1 volt per division. So we're looking about, I'm going to expect 5 volts. So let's have a look. Let's get a nice ground point. Ground point there. So we're looking for pin 12. So 2, 3, 4, 5, 6, 8, 9, 10, 11. So that's 12 there. And that's actually, DC couple would be helpful. So just double check that those pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's off the scale. So not easy to do this one-handed, but I'll try. The ground reference point there. DC, that's okay. So that's 1, 2, 3. It's actually that's on. What are we on? 2 volts per division. So it's actually more than 5 volts. So I'm going to try and select anything else on the front panel. No control area at all. So I think it possibly is that chip that's causing the problem, IC1. So I'm going to try and track another IC down. I think I might change that first because at least it's socketed. And change that first, see if that fixes the problem. Because I'm wondering what's happened if someone's shorted, if this battery's been messed about with and it's shorted out and it's probably blown the chip up. So we'll give that a go. I'll have a look on eBay so we can find some a replacement IC for this. But it's let's just check the IC number. So IC1 is an MP4480 microprocessor. So I'll try and track one of those down. I'll give the socket a clean up, and then we'll see if that improves things.